we are going to calculate the equivalent resistance of this circuit. This is a simple circuit and with just a single trick which we'll discuss. So the first thing you need to do is to add some labels to the nodes. So I added A, B, C. You can add them in any order as you like, and this is also not required, but it makes the circuit solving and keeping track of the process much easier. Probably you can ignore this step in the future after you have solved a lot of circuits, but for now, if you're a beginner, you should definitely use these labels. So the first pair of resistors that we can easily merge together is these two. So 4 and 20, they are connected in series, and we will go and merge them. So for series resistors, we know, so to combine two resistors, we just add them together, so they will become 24. I did not change any other resistors or connections in the circuit, but I wrote A equals C, D equals E, and F equals G. What this means is you can see A and C, these two nodes have a conductor connecting them, which makes the voltage level at these two nodes equal. Also the same applies for D and E and F and G. So we can consider them a single point, which will come in handy. Now we will try to see which resistors are connected in series or parallel. So there are no more series resistors that we can merge together now, but there are actually some parallel resistors. The first one is here. You can see this 12 and this 12. So they both have two ends at the same point. So you can see this both of the ends of these two resistors are connected to G and C, so we can actually combine them. And then 10 and 15, they're connected here and they're connected here. Also 12 and 4, so they're connected to D and E, and on the other end they're connected to F and G. So drew the circuit as such, and you can see these three pairs are in parallel. So if two resistors are in parallel, we will use a formula to get the value if we actually combine those resistors. For series resistors, it's very easy. We just actually add them, arithmetic addition. But for parallel, we have to use a simple formula. So this is the formula. If R1 and R2 are in parallel, then R1 plus 1 by R1 plus 1 by R2 equals 1 by RP. After solving, we get this formula. So I used that formula to calculate these values. 10 and 15, combining them gives me 6. 12 and 4, I get 3 out of that, and 12 and 12 gives me 6. So I replaced those in this circuit, 6, 3 and 6. And you can easily see the changes. If you have difficulties, you can just see the labels. That will actually help you to track. Now the tricky part of the circuit. This line A and C. So A and C are actually the same point, and now we will merge them together. So you can see that 4 and 12, these two resistors are connected to B, and their other end, one is connected to A and other one is C, but A are C and C the same thing. So we are going to merge A and C, which will also bring this resistor 6 in parallel to 424, because this end is the same and also this will become same. So if we go to circuit, you can see now 12 and 4, These two resistors are in parallel now, and also 6 and 24, these two resistors are in parallel. So I apply the same formula that I used before and to here. So I calculated 4.8 and 3, replace those values here, which gives us these two resistors in series. I combined and which gave me 6, and then 6 and 4.8 are in parallel, which gives me 2.67, and at the end all three of these resistors are in series. So simply adding all of these values gives me the final equivalent resistance